Hi there. Welcome to the second in our series of talks preparing for the Building Modern Web Applications and Services program at Regensburg. Time is marching on now. I'll be with you at the end of next week. Last week we had a quick review of HTML and CSS. In particular, we looked at these topics here: simple case study, templating in general, deployment issues, and Surge. You can see the videos here if you want to watch back. Sometimes people watch back at a quicker speed. Today we're going to look at CSS frameworks. A deep understanding of CSS is not really essential for our program, but a light understanding of their purpose and then how to achieve some basic layouts would be useful. So we're going to start with semantic UI, which is a framework that we're going to be using in our course itself. And then we're going to walk through a series of case studies of using semantic UI in a simple static web page. In fact, that's all done in the lab here. If you had a look at any of the labs from last week, we ended up building a web page that was based around a simple promotional site. That web page, if you recall, was just 5 or 6 pages really, with a fairly basic layout. The labs today are going to take that website and turn it into something a little bit more sophisticated. In fact, it'll start to look like this here, styled using semantic UI. Okay, let's talk about that then in a bit more detail, and we'll go through our first talk here on just what the purpose of these frameworks are. So frameworks are widely used in the industry now, started to emerge about 10 years ago or so, particularly as CSS2 and 3 were proliferating, and it was becoming quite a challenge to build cross-browser attractive interfaces. That is, retaining the same CSS code base proved to be a bit of a challenge. So framework was an attempt to encapsulate in a library a CSS style, and in your web pages you would just use classes and maybe IDs from that library, and also JavaScript, rather than composing CSS from scratch for each application and website you would be developing. So there's quite a range of these now. Foundation is a very common one. Pure CSS is out a little bit more recently. You can find loads of sites here giving you information on the more popular ones. They usually aim to keep you focused on your HTML, HTML5, and relieve you of the burden of building CSS. To do that, you are often composing just your pages using predefined classes, and those classes would come from the library you would have included. In semantic UI, it's a popular one. We will be using things like container, segment, header, image, grid, row, column, and these have specific meanings in the context of semantic library in particular. Semantic library uses the UI prefix to separate its classes from other frameworks that you could also use, but normally we just stick with the one framework. So in the lab, we have a project like this, which contains a lot of content we've assembled in last week's labs. Most of our files are in images in a separate folder called assets, and then our core HTML is there in separate pages. We could incorporate semantic directly into our project like this. We download a semantic framework from its GitHub repository, or it's available as zip, unzip it, and then once we get unzipped, we have the full library within our project that we can link to and use. And here's how we might do it: a simple href directly into the CSS file. Perhaps also include some JavaScript, but we'll leave that out for the moment. In the little lab you'll do today, we more or less get rid of all of the CSS we hand built, and we just leave one rule in there to just control one of the banner images. And our job then is to convert our previous page, which was hand-coded CSS, into a semantic UI site. Some of the things we change immediately. We would be looking at margin with auto. This is a standard little trick we do in CSS to ensure we've got even and balanced left and right margins. Well, in semantic UI we use UI container, and we generally put most or all of our pages inside a container class, as we're showing here. These containers now are much more carefully managed than our simple margin auto trick we would have been using. We have quite sensible and attractive proportions managed automatically by our CSS framework. The next component we would use class would be segment. Once you bring in a segment, then we give all of the enclosed elements a nice little border and a little bit more proportions. So this gives us, you can see it here on the right, light frame around each of those sections, and it starts to give us sort of a panel feel, and we can choose to have a little bit of depth in that if we want as well. So all our pages then become include the semantic CSS library. We use container more or less everywhere, and we also use segment to encapsulate most of our sections. And our page starts to come like this. Now, segments in semantic have a number of variations. Plain segment, raised segment, or stacked segment. And you can see here this is a subtle difference in the way in which the frame is presented. And these are very easily turned on in our library. All we do is we say UI raised segment, and we get the effect. Okay, that's simple enough really, just to get started. Let's look at a little more detail now at some other aspects of semantic, in particular grids and images. And again, we're illustrating this via our little project in the lab 1 of this week. So grids are quite a challenge to get implemented reliably, and there have been many grid frameworks over the years. In fact, all CSS frameworks introduce some grid system of one kind or another, and they're usually based around fairly similar principles. In semantic UI, we've got quite an attractive and easy to read set of classes. We can say 4 wide column, and if we get a 4 wide column, it means the entire width of the viewport is divided into 16, and 4 gives us 1/4 of that. So we've got some room for getting our proportions right. These columns then, it's a 16 width system. Most of the frameworks pick 16, or some of them maybe pick 12. And once we assume we've got that number of columns, then we can divide up the screen in a fairly balanced manner easily enough. Here's another example, a couple of 4 wides. The 3rd, 4th wide column here fills up the row. So from here on, we're moving on to a new row, and that new row then allows us to start with a 2, an 8, and a 6. You can see the idea there. Rows can also be explicitly or implicitly defined in our layout, and this means we're using the row element class, as we evolve the grid structure. So here's an example from the documentation: 4 column grid, explicitly including a row here. You'll see that row is 3 columns, and then we're closing the row here, and then we're just proceeding with a standard column layout thereafter. And the framework is smart enough to figure out roughly what we're trying to do, so we don't have any further qualifications in the columns themselves. Our entire grid system here is based around 4 column grid. In our little lab, we do some experiments here. We take our header and we try to take it from an unstructured format above to a cleaner, more balanced layout below. And we can do that by dividing the header into 2 columns. So those 2 columns, you can see, have now been introduced directly into the element here. That is, we've got a 2 column grid segment, and then we've got column 1 and column 2. And you can see those columns reflected in the way we've laid out the header. Here we do some alignment modifications. So 2-column center align grid segment. So what we've done is we've moved very subtly the text into the center and also into the middle. And you also see the image moving into the middle here as well. So that gives us a nicer balance. And this middle alignment then, if we complete it, gives us the final layout structure. This is a unique feature then of the particular framework we've selected, the semantic UI framework. That is, the framework itself allows us to read out as a sentence the style we've decided to associate it with our header. It's a 2-column center aligned, middle aligned grid segment. Segment means we get a light border around it. Grid means it adheres to a grid system. Center and middle aligned are fairly self-explanatory. And 2-column predicates the grid parameter. Images then are another bone of contention in display. Last week we spoke briefly about maybe just using the height of the image to ensure we had the correct balance or positioning of the image on screen. With semantic UI, we try to not use explicit widths or heights, and semantic proposes that we just stick to using words to describe the images and let the framework make a choice then as to what's the appropriate size, which is indicated here. So this gives us a much more higher level way of composing the page. We talk about mini, tiny, small, medium, huge images, and leave the final decision on the width and height to the framework itself. The framework also proposes variations on these images, fluid, circular, rounded, and you can read the documentation on those if you choose. In our little example from last week, we wanted a kind of sponsors set of images across the bottom of the page. Unformatted, they didn't look very attractive. But if we bring in grid, 2 rows, 1 row single column, 2nd row 3 column, then we get a nicely laid out series of images here. So in this example, we are using the if I just get that right here, sorry. We are declaring the entire section to be a center aligned grid segment with the first row here containing just text. The second row here is 3 columns, and then you can see the 3 columns listed here with just the image, and each image is a default size. We're saying UI image, so we're not specifying a specific size. Okay, finally, getting a grid working on our little example. 2 rows. First row is 3 columns, second row is 3 column, and the entire thing is engraded in grid segment. And then inside each of those 3 column sections, we're separating out the columns. So you can see the code for each grid coming in here. Each of the actual text panels. That's the first row, and in here is the second row. That's basic guide to using semantic in that context. I'll just march on with one more example, and this time we're looking at tables. Not using tables that much in this particular lab you may have looked at today, but tables are very attractively formatted in semantic, and just looking at a few examples here is interesting. Standard table. We've got a header, we've got some labeling on it, we seem to have some pagination. Well, that's the code here for that. And you can see up here the classes we're using are UI celled table. This is the ribbon that appeared on that page, and here we've got a pagination menu and structure. So all of that is rendering quite attractively here like this. But notice we've not composed any CSS, we're just using classes having included the framework library. Some more examples here. This is quite nice. We've got a rating system, various alignments and centering and so on. And again, that's the example of how it might look. Again, I won't go through this in any great detail because we'll stick with plain tables ourselves anyway, but it's useful to know that these features are available. This is like a little social network type layout, and here's the actual structure. So here we're using, if you look just very briefly at the table we're using here, UI very basic collapsing cell table. So once we get to know this little language, then we can start to almost speak in semantic UI. Single line tables, there you see single line is used, and stripped tables. So here we're seeing every second row has got a different, slightly lighter hue. Here, here, here. Again, if we were doing this by hand, we'd have a lot of work to do, but in semantic UI, we just put in one word, striped, and we're done, and the framework will figure it out. Color tables, it's fun too, and that's quite an attractive layout we can aim for. Okay, I'm going to take a quick look now at the lab you're doing, if you do decide to do it below. Semantic UI Part 4. This is the ultimate effect we wanted to achieve, and we started with, and this is what we want to achieve. So you can see there's a nice change here in structure. This was our previous version from the first lab below, and this is where we'd like to end up. So it's a short case study in what you would do to do that. Semantic UI provides comprehensive range of icons. These icons actually come from an open source project called Font Awesome, I think. So they're just using or reusing widely available and updated fairly frequently icons. We can take those icons directly into our project, standard social media ones, for instance, here. Colors. The framework defines a range of human readable colors we can use. They're mapped directly to these hex values, so we can keep our code without being encumbered with these numbers. And of course, we can redefine these numbers if we want. Here is how we return our panels into a different color. I want the column to be red, so I just say red column becomes red, and you'll notice that the text becomes reversed video immediately. So I don't have to do any work to get the text to appear white or blue in this instance, even though it was different colors in the original uncolored one. So here's an adjustment made. Just I want red, orange, yellow, olive, green, and teal columns, and we get our page reset. Our icons, we're selecting again from the Font Awesome suite, which is documented on the semantic UI documentation. Change their size to be huge, we get that effect. And we might align them left and right inside a simple grid system. Our segments, we choose to raise them a little bit, makes it a little more attractive, and we pad them. And we could also stack them if you want. So here is packed stacked grid segment. And if we look here, we can see just a subtle change in the way it's structured is visible down here. So there you can see it's packed and stacked. The images on our pages, we're left at default from the previous lab. We may have set the height maybe to control them. In semantic UI, we can just give each of the images a size, and it'll be resized then directly using the framework itself, which is much more attractive. So because our grid was 16 units, we're tracking 8 and 16 as the left and right sizes of these pages. And you can see here how it's worked out. 8 column wide, and then our image 16 wide for the wider image, and then 8 and 8 for the second and learning paths image below. So this has all been achieved without writing any CSS. All I'm doing is using my knowledge of the CSS grid system as in semantic to very quickly roll out an attractive and reasonably balanced page. Now the banner is a bit more complicated. We've got to break out of the container temporarily, so we can set the banner to be the full width of the viewport. It's currently not constrained like that. And a little bit of work to do there with the smallest piece of CSS we need. That is, we're using background images as opposed to standard images to render the banner. So we're stretching the background image to the width of the page, and you can see a little bit of work here to just do some alignment on that. Okay, that's basically it. One last point. Our page as structured behaves reasonably well on a conventionally laid out viewport, let's say the width of a tablet screen or maybe a desktop. But if we collapse the page to the size of maybe a mobile phone screen, it doesn't really function so well. We would like the page to be what's called responsive. And responsive is a web page that can render correctly on a variety of screens, including the extremely narrow screens of mobile phones. Now, this was one of the motivations for CSS frameworks in the beginning, really, was to be able to cope with this type of variation. And doing this type of variation manually is quite a challenge. However, we're using this framework. This framework supports responsive grids, so we can more or less turn on the feature and expect it to behave reasonably attractively. So here is our stackable grid. And just that keyword stackable is enough. Stackable means that if the viewport is too narrow, put the individual columns one on top of the other. The browser will make that decision for us when it sees the dimensions of the screen. So we make everything stackable really in our grid system. We're just bringing in this stackable keyword, and it is a small change, one word change, to achieve a fairly dramatic effect on the layout. Stackable for each of the pages, and we're done. Okay, last point. Semantic UI libraries, we could download them from the semantic framework and dump them all into our project. That's fine. This means that inside our project then we're linking an absolute path to our own project. Or we could pull in the frameworks from a CDN. Content delivery networks host lots of popular and common frameworks globally. It's quite likely there's one very close to wherever the browser is interacting with our website. And it'll probably come down faster from that than even from our site. This means that in our page, we needn't bother downloading the framework. We can just include it directly here by using the link directly to the CDN URL, which we can find just by a simple Google search. So we're using this absolute path to the semantic framework libraries. Okay, these are the classes we've used in our short discussion. Container is a way of establishing our margins sensibly. Segment is a raised panel. Header is like a H1 or a heading construct. Image is a way of assuring the image is sized appropriately. Grid, we've seen in action, allows us to have a grid system. Rows and columns are part of that analysis. And we saw some quick examples of tables and the icons that are available. Now, we use these in the context of if you think of them of adjectives, raised, stacked, padded, left, center, right aligned, and then also single line, cell collapsing for tables, and other qualifiers for the images themselves. This is the language then we'll use in our labs. In fact, for the course we'll be doing in Regensburg, we'll be not really needing to get too much into detail here, but you might want to explore the framework yourself at some point later on for additional features. Semantic UI, very easily located. Just search for Semantic UI framework, you get it immediately. And the attractive element of the framework is that the documentation is very easy to read. If you want to understand how header works, for instance, it gives you examples, and then you can just click here to see what the source code looks like. So it's very simply done and nicely laid out. Tabs are a popular feature. We're looking at how the tabs are structured. Again, we can just reveal the code for the tab here, and we see here's the structure. Okay, that's it really for our quick talk on the frameworks. I'll put this video up a little bit later on. I'll just note one thing here before I finish up. The chat window here is available. You must have a Gitter account, and if you have a Gitter account and you're signed in on Gitter, then you will be able to enter this chat room. So to get a Gitter account, just go to gitter.im and sign in there. And when you sign in, you'll be able to gain access to the chat room I've just looked at. You can press this button to operate the chat room in a separate window, as I'm doing here. So when you come into the chat room, anything you say will be visible to everybody. So please note that. And some people have already joined here, which is great. I will go online tomorrow, that is Thursday afternoon. Let's say from 3 to 5 Irish time, which might be 4 to 6 in Regensburg. So please feel free to drop in there if you want a direct chat. One last point before I wrap up. I've changed slightly the JavaScript slides, which I plan to do also release this week. So I've restructured them a little bit into a series of shorter talks on some of the basics of the language. If you already have JavaScript, you can skip over these very quickly. If you already have another programming language, you might just want to observe these to see how your knowledge of Java, for instance, could relate to JavaScript. But I'll talk more about those in the next video. Okay, thanks for your attention, and I'll be in touch again shortly.